Hi friends, and today we'll be talking about componendo and dividendo and similar operations which we carry with ratios. Okay, so let's go step by step. I'll give the header to this discussion as componendo and dividendo. Okay, now the point which I want to make here is why are we recording this? Because it's a very small part and it can be understood very easily through a video. I'm just trying it. And best part is it will save good amount of time from our instructions. It's a very small technique which can be used in a lot of problems, and problems have been asked in the past in different entrance exams. Okay, so it reduces the problem or simplifies the problem for us. So let's start with the first operation. The basic requirement to use componendo dividendo kind of operations is the given information should be two ratios, A by B equals C by D. Okay, and if these ratios, two equal ratios are given, then only you can talk about this all operations. So the first operation is called as componendo, COMPONENDO. So what is componendo? If you have two equal ratios, if you add 1 on both sides of this ratio, now if you simplify this, you cross multiply, you will get something like this: A plus B upon B and C plus D upon D. So essentially, if I call the given structure initially was numerator upon denominator, then post applying componendo. So what is componendo? Adding 1 on both sides of two equal ratios. So on doing componendo, what kind of structure do we get? Numerator plus denominator upon denominator is the structure which we have achieved. So if we started with numerator upon denominator, then we have come into numerator upon denominator kind of a structure. You can see numerator plus denominator upon denominator, numerator plus denominator upon denominator, that kind of fact I am sharing. So essentially let's get the final version here. Okay, and it is called numerator plus denominator upon denominator structure. Okay, so this is the name we will give to this particular structure. Now the second thing is called dividendo. Okay, so if I have two equal ratios and I subtract 1 on both sides, then I get A minus B by B equals C minus D by D, and this structure becomes numerator minus denominator upon denominator. Okay, so this structure is called as numerator minus denominator upon denominator. Yeah, so let's see the next structure, and the next structure, or rather the next operation, is called componendo and dividendo. Okay, so what is exactly componendo and dividendo? If you have two equal ratios, which is in the form of numerator by denominator, componendo and dividendo means first carry out componendo, okay, then carry out dividendo, combine these two, and get something called as componendo and dividendo. So essentially what we are doing, we are adding 1, subtracting 1, and then dividing these two ratios. So whatever ratios we have produced here, these two ratios, okay, rather C plus D by D, C minus D by D, these two equations, we actually take a division of these two equations. Okay, division of these two equations means this equation and this equation. Okay, so once we take the ratio or the divisions of these two equations, we get A plus B upon A minus B equals C plus D upon C minus D. Okay, that is fine. Yeah. Now once we have this particular structure, now just let's pay attention what kind of structure we have recovered here. So this particular structure, if you try to understand the structure of this, it is numerator plus denominator upon numerator minus denominator if you have started with numerator upon denominator initially. Okay, so you can see that numerator plus denominator upon numerator minus denominator kind of structure is being achieved here. Okay. Now, once these three things are over, there are some two subsidiary or maybe a simpler operations also. One is called as invertendo. And what is invertendo? That if I have A by B equals C by D, It's very simple. Invertendo means just invert the equations. So denominator will become numerator and numerator will become denominator. Okay, so that is just, that is obvious or common sense. One more common sense is called as alternando. I'll just correct the spelling here. Alternando. Okay, so it is just that it's not a big deal. You just take this B here and take this C here. You alternate them. So you'll get A by C. You'll get this as A by C equals B by D. You just have cross multiplied one of the pairs. Okay. So this is invertendo and alternando are very basic things. But the prime things here are, in as much as problem solving is concerned, which we'll see further, componendo, componendo and dividendo are a must. Now once we have learned what different operations we have studied, let's try to understand what are opposite operations of these operations. So opposite operations of componendo, dividendo and componendo dividendo, that is what we are going to study now. So the first is, imagine you have A by B equals C by D and you did componendo. Then you get A plus B upon B equals C plus D upon D, correct? Now this is what structure? Numerator plus denominator upon denominator. This has been achieved. So now think about, okay, if there is a problem which is in this form, then how to go back to the original form, that is the primitive form, which is this. So you have to apply opposite operation of componendo. So what is componendo? Componendo is add 1 on both sides. So what is the opposite operation of addition 1? It is subtraction 1, which is what we have named as dividendo. Okay, so if you do dividendo on a structure of this form, that's why remembering structure is important rather than the actual values. So whenever there is numerator plus denominator upon denominator form, you can apply dividendo to reverse it to the original form. Similarly, if A by B equals C by D, you apply dividendo, that means you have subtracted 1. So you get A minus B by B equals C minus D by D. That means what form is achieved? Numerator minus denominator upon denominator. To reverse this, you apply the opposite, which is called as componendo. Okay, it's plus 1, which is componendo. So henceforth we'll take only C for componendo and D for dividendo. Okay, and finally the most important thing, just think about it. If I have A by B equals C by D and I apply componendo and dividendo together, that is the ratio of those two values. So I'll just represent that as componendo and dividendo. Then what do we get? We get numerator plus denominator upon numerator minus denominator on either side, that is numerator plus denominator upon numerator minus denominator structure. Now if I want to go something, if some problem is in this form and I want to take it back to the original form, then what should we apply? What is opposite operation of componendo and dividendo? It is not dividendo and componendo, it is same componendo and dividendo. So let us see how this will happen. So imagine they have given us this and we are applying on this componendo and dividendo. When you apply component dividendo, what exactly does happen? This is numerator, denominator, numerator, denominator. So when you apply component dividendo, you will write numerator plus denominator upon numerator minus denominator. That will follow on the other side also. Okay, now if you simplify this, you will see B gets cancelled here, A gets cancelled and D gets cancelled here and C gets cancelled. So typically what you are getting, 2A upon 2B is equal to 2C upon 2D, correct? Yeah, basically here minus and minus becomes plus, please be aware of that. And 2 also you cancel, so you get A by B equals C by D. So have you reached to the original form from where we actually started? Okay, so basically if you want to simplify any problem which is in this form, you can, or rather you should use componendo and dividendo structure or rather operation. Okay, now can you always do this kind of calculation to simplify and come to this? That is quite tedious, right? So what we do, we just observe what actually happened. So if something was in this form, I apply componendo and dividendo, I got this. Okay, I'm not writing the right hand side, things are changing accordingly. Now you can see what is happening. Things which are having same sign is coming in the numerator. Things which is having opposite sign is coming in the denominator, but it is coming from the numerator. We have not written here minus b. we have written here plus b, that means it has to be fetched from the numerator. Okay, so this is a very good problem solving technique. Whenever you have a componendo dividendo structure, then you should always do this. Like for example, let us identify, I am just asking a question, problem, let us take a problem. Identify componendo and dividendo structures. Okay, and also identify componendo dividendo structures individually. So let us take the first form, a plus b plus c upon a minus b plus c equal to something. Does it have componendo or componendo dividendo structure or dividendo structure? So you can see here, these are two terms which are having same sign, these are also having same sign, this is having opposite signs, correct? These are having opposite signs. So it is a componendo and dividendo structure. Like let us take one form like this, x square plus 1 plus x upon x plus 1. Now if you see this kind of thing, what is happening here? You can see this term, not rather that term, it is this term which is there here also, and this is extra. So can you say that this is in the form of numerator plus denominator upon denominator? So it is which form? Only componendo form. Are you following this? So how will you simplify this structure? To simplify this, you will apply dividendo. Okay, I hope this particular strategy which I have discussed with you above. So rather it is very simple, that why do we actually carry out doing finding out what are the opposite operations of componendo. We said it is dividendo, dividendo we said it is componendo, and component dividendo we said it is component dividendo. What is the actual need? To simplify expressions. Okay, now let us go ahead and do one serious problem. From there you will come to know what exactly I am talking about. So the problem says, if a by b equals c by d, then prove that pa square plus qb square upon pa square minus qb square is equal to pc square plus qd square upon pc square minus qd square. This is what we have to prove. So what I do, I start with the given. So what is given here? So I'll write the heading as solution. What is given is a by b and c by d. Now I observe what is asked. We will need a square and b square. So what I'll do, I'll square. So I'll get a by b square is equal to c square by d square. Then what is the next requirement? I want p with a square. Okay, and I want p with c square also. So what I'll do, I'll multiply by p on both the sides of the equation. Then I multiply q in the denominator of both the sides. So what we can say, multiply by q by p by q on both the sides. So we have achieved this till here. Now what is the next step we want? We want addition and subtraction structure. Can you see that? Addition and subtraction structure. So what I do, I apply component and dividendo, because I am getting numerator plus denominator upon numerator minus denominator kind of form here. Okay, so I'll get y component and dividendo will get pa square plus qb square upon pa square minus qb square. Similarly on the other side also same thing will happen. pc square plus qd square is equal to pc square minus qd square, and hence we have proved it. Is it making sense to you guys? Yeah, let us take one more problem, and here in the next problem, of course we will not solve this problem completely, but I'll just show you how it is helping in simplifying the problem. So here I'll show you why opposite operations are required. So you can see 2x cube minus 3x square plus x minus plus x plus 1 upon 2x cube minus 3x square minus x minus 1 equals 3x cube minus x square plus 5x minus 13 divided by 3x cube minus x square minus 5x plus 13. Now this problem is given and they have asked us to solve this. Of course we will not solve everything. So if you see here, there are few things which are same above and below. So these terms are same, these terms are also same, these terms are same, these terms are also same. And what is opposite? Opposite is these terms are opposite. We can say opposite in signs, I mean by that. These are opposite in sign, these are opposite in signs. Okay, so now what we'll do, we'll apply componendo and dividendo. So when you apply componendo and dividendo, same terms, same sign terms will come in the numerator, and opposite sign terms will come in the denominator from the numerator. Okay, then on the right hand side what will have, 3x cube minus x square have same sign above and below, they will come in the numerator, and 5x minus 13 will come in the denominator from the numerator. Okay, so by that we have got this equation. Now here we will divide the problem into two cases. You can see that if x is equal to 0, then the problem is satisfied, no? Therefore x equal to 0 is a solution to the problem. What is case 2? What is the other possibility? If x is equal to 0 is one case, the other case will be x is not equal to 0. And why are we talking about x is not equal to 0? Because I can factorize x square in this given form. तो अगर x square को हम कॉमन लेते हैं तो 2x माइनस 3 यहाँ पे आएगा और x प्लस 1 आएगा इज इक्वल टू, यहाँ पर भी हम x स्क्वायर अगर कॉमन लेते हैं तो 3x माइनस 1 अपॉन 5x माइनस 13 आएगा. अब इस x स्क्वायर को हम काट सकते हैं क्योंकि हमने एज्यूम किया x इज नॉट इक्वल टू 0 और उसका कंसिडरेशन ऑलरेडी हो चुका है सोल्यूशन में. सो दिस इज वन सोल्यूशन. नाउ if you see this equation, now what is left to solve? It's very simple. 2x minus 3 multiplied by 5x minus 13 is equal to 3x minus 1 into x plus 1. We have to solve this equation and it's a quadratic. Okay, once you solve you will get two more solutions from this equation. So x equal to 0 and two solutions coming from this, if at all it is solvable, depending upon the delta, which we'll study further. We will say that these three are the solutions or two are or one are the solutions to this equation. But the major point here was that this was a very complicated problem which got simplified into such simple form, which got simplified to more simple form. Or else imagine how will you solve this particular problem other than this method. Okay, so knowing the opposites of operations actually come from this kind of problems, and you will see a lot of such problems coming ahead. Yeah, thank you very much guys. I hope you have understood. Now you can attempt the sheet which I have given. Thanks.